All right, well, we definitely have a topic that we could use a little refresher on. Let's focus on trig equations tonight. So basically, there's 4 steps in solving a basic trig equation. Step 1, and you can kind of slow it down in any language you like, determine the reference angle using inverse sine or inverse cosine. 2, determine the quadrants. All right, big deal. Quadrants in which the terminal rays of the solution lie. 3, if you need to sketch it out, go ahead. Again, I put if needed there. And 4, calculate the solutions. So on question 1 here, we're going to start with the absolute most basic trig equation there is. Okay, and this is just like a linear function. So our goal is just to get cosine theta by itself. All right, so I'm just going to box it in. That's who I need to get alone. All right, now again, if that cosine bothers you, call it x. It's the same idea. What would you move over first? Okay, well, hopefully you said 1. So again, this is just a basic equation. So I'm going to say equals -1. And lastly, to get this by itself, I would then divide by 2. So I'm getting -1/2. Okay, so step 1 is done. We've got the trig function by itself. All right, step 2, I need to get my reference angle. Now, this negative, I want you to circle and off to the side. This is telling you the quadrants that you're sitting in. So let's do our all students tip cows. Okay, now we're cosine, and we need to be negative. So I'm just going to stand in each quadrant. In the first quadrant, everybody's positive. So you can't be there if you're cosine and you're negative. Quadrant 2, sine is positive. That means everybody else is negative, so that's a winner. Quadrant 3, tangent's positive. Therefore, cosine is negative. That's a winner. And then in quadrant 4, cosine's positive, so that one's out. All right, so I know I'm in quadrants 2 and 3. Now let's get that reference angle. Okay, if you can't do that in your head, if it's not a number you know, or you forget, you get nervous, use your calculator. You're basically doing inverse cosine of 1/2. Okay, not basically, that's exactly what you're doing. But 1/2 is a number you should know. So do you know it without the calculator? Who do you take the cosine of to get 1/2 as an answer? Well, is it 30, 60, or 45? Hopefully you said 60. Okay, so 60 is my reference angle. Now you'll notice I'm not actually going to use 60 because that's in quadrant 1. But I am going to, use 60 to get the other answers. I'm going to say this is 180 minus 60. And this angle is 180 plus 60. So I'm going to say my two answers are 120 and 240. Now, you'll notice off to the side, I did 0 to 360 and 0 to 2 pi. These mean different things. It's how you're going to represent your final answer. If we said 0 to 360, right here, we'd be in great shape. However, if we wanted 0 to 2 pi, we have to slow down and convert those back into radians. So, very simple. I'm just going to say it's 120 times pi over 180. All right, so my zeros cancel. My 12 and my 6 reduce. Let's see, 6 goes in there twice and 3 times, so that one's going to be 2 pi over 3. And I would do the same with the 240. 240 times my pi over 180. Let's see, again the zeros cancel, 6 goes into both, 3 here, 4 here, and I would get 4 pi over 3. So those would be my two answers if they want me to express it in terms of pi. So just look carefully on the short answer. Now, of course, they can get a little more complex, like in number 2. We have a quadratic this time. Okay, so again, I'm still going to box it in. I'm still saying I want this term by itself. I want the cosine x by itself. So the first two moves should be pretty straightforward. Hopefully you're saying add over the 3. Okay, and then I hope you're saying divide by 4. So cosine squared x equals 3/4. Now, if it was cos x, I'd be done and I'd grab my calculator, but it's not. There's this squared hanging out. How do you get rid of squared terms? Well, it's very simple. All you do is you take their square roots. So I'm going to take the square root of this side, and I'm going to take the square root of this side. Now, don't forget you get a plus and minus when you do that. Okay, so that square zaps out that square root, and I get cos x equals plus or minus. And that radical, remember, is on both numbers, both the top and the bottom. So most people are going to write them separately as radical 3 over radical 4. Now look how handy that is. You actually know one of those numbers. You don't know the square root of 3, but you should know the square root of 4 is 2. Okay, so I'm getting cos x equals plus or minus radical 3 over 2. Now again, I would grab my calculator if I didn't know that answer and take cos inverse to get rid of a cos, of radical 3 over 2. Now that should be a number we know that comes from our chart. Is it 30, 60, or 45? Hopefully you said the reference angle is 30. All right, now let's talk quadrants. Notice it has both a plus and a minus. So what does that do to your quadrants? Well, you can be positive or negative. So basically that's going to cover all the quadrants because cosine's positive here, it's negative here, it's negative here, and it's positive here. And I had that plus and minus, so I need basically 30 degrees in every quadrant. So let's start in quadrant 1. That is just plain old 30 degrees. In quadrant 2, it's 180 minus 30, so that gets me a 150. Quadrant 3, that's 180 plus 30, 210. And then don't forget we're going to use 360 here minus 30, 330 for my 4. And again, if I wanted them in radians, I would just be multiplying by my pi over 180. Alright, so we're going to make them tough for each one we go through here. Question 3. Alright, I've got 5 sine x cos x plus 2 sine x equals 0. What does your gut tell you to do? You've got a plus sign and you've got some term here, plus some term here. What does your gut tell you to do? Hopefully those 3 simple letters are popping in your head. G, C, F. Notice each side of the plus sign has something in common. I'm basically going to take out the sine x here and the sine x here, and I just put a slash through them so I realize what I'm taking out. So if I pull out a GCF of sine x, what's left? Well, I'm left with a 5 and a cos x, and here I'm just left with plus 2 equals 0. Okay, so literally put a slash through it so you see that it's gone and just say what's left then. Alright, now it's like GCF factoring, which it is, and I'm just going to tee it up in both spots. So I'm going to say when does sine x equal 0 and when does 5 cos x plus 2 equal 0? Let's see. Let's start with the easy one. Sine x equals 0 is already solved for us. Now, that's not in our chart, but it is on the curve. So I'm going to slow down and graph my curve out. Got my pi over 2, pi, 3 pi over 2, and 2 pi. And hopefully you can kind of draw it with your finger in the air. It starts at 0, 1, 0, negative 1, 0. So when does sine x equal 0? Well, it happens at 0, at pi, and again at 2 pi. If I needed those in degrees, that's 0, 180, and 360. Remember, it goes 0, 90, 180, 270, 360, just like the unit circle. Now on this side, again, I'm just going to get cos x by itself. So what does your gut tell you to do? Hopefully you said subtract the 2 over. Almost by itself, and now we'll divide by 5. So I've got negative 2/5. I want to be clear about that negative. That is my reference angle quadrants. All students tip cows. I need cosine to be a negative number. So I'm just going to walk through all 4 of them. In the first quadrant, cosine's positive, so that's out. In the second quadrant, cosine's negative. Winner, winner, chicken dinner. Third quadrant, cosine's negative. Winner again. Fourth quadrant, cosine's positive, so it's out. Now 2/5 is not a number I know off the top of my head. It's not in my table, so I need my calculator. So I'm going cos inverse of 2/5. And I grab my calculator. Let's see, I get 66 degrees to the nearest degree. And again, I wasn't too specific on the rounding. So now I just got to watch my quadrants. Again, I'm going to do 180 minus 66 and 180 plus 66. So I get 114 and 246. So all in all, I have a 0, a 114, a 246, a 180, and a 360. Alright, we've got a couple more to go here, and again, they get nastier as we go. So solve the equation cosine of 2a minus sine, or 3 sine a minus 2 equals 0 for all values between 0 and 360. So again, that's just telling me answer in degrees. Now, there's a big brain buster in here. Watch this term right here. What is that puppy called? Hopefully you recognize it as a double angle. How do I know that? Well, I think it's fairly obvious. They're taking angle A and they're multiplying it by 2. Hence the word multiplying by 2 or double angle. Alright, so that tells me I got to go to that formula sheet and I got to look at my double angles. Alright, so there they are. I pulled them up. And life is always about options, so of course you have options. There are 3 different options for the cosine of 2a. So here's what I do. I basically scratch it out of the problem. Okay, I say, if I scratch that out, what trig function is still left in this equation? Okay, who do you still see here? Well, I see sine. So I look at all three of these equations, and I'm going to use the one that only has sine. So to me, this one's out, and this one's out, and this is my winner. So I'm going to substitute that in. 1 minus 2 sine squared a minus 3 sine a minus 2 equals 0. And it's that simple, but you have to recognize it as a double angle. Okay, now take your time in cleaning it up. So that's a negative 2 sine squared a minus 3 sine a, and 1 minus 2 gets me negative 1 equals 0. Now most people don't like negative coefficients, so it's fair game to change all of them. So I'm going to go 2 sine squared a plus 3 sine a plus 1 equals 0. And I'm going to hope this factors. If it doesn't, I can use quadratic formula. So I'm going to go 2 sine x and sine x. My only options for 1 are 1 and 1. And I'm going to go plus plus. Let's just verify. That's 2 sine squared plus 2 sine plus 1 sine gets me 3 sine plus 1. And I'll tee it up there. So 2 sine x plus 1 equals 0. And sine x plus 1 equals 0. Okay, again, solving simple equations. I hope you can do that part in your head by now. Subtract 1, divide by 2. And here, sine x equals negative 1. All right, again, quadrants. All students tip cows. Don't forget the quadrants. You're going to start in each one, and you want sine to be negative. So in the first quadrant, everybody's positive. That's out. Second quadrant, sine is positive. That's out. That means I'm left in 3 and 4. Okay, so let's get our reference angle. If you can't do it in your head, it's inverse sine. But again, this is one we should know. The sine of who is equal to a half? The sine of 30. So I'll go ahead and get my angles by saying 180 plus 30 and 360 minus 30. So that gets me 210 and 330. And now this pair here, again, negative 1 is not in the table, but it is on the graph. So I'm going to plot my points, pi over 2, pi, 3 pi over 2, 2 pi. And again, if you can draw it in the air with your finger, that's recommended. We're going to go 0, 1, 0, negative 1, 0. And you're literally asking yourself, how many times does that thing hit negative 1? And it does once right there at 3 pi over 2, which is really 270 degrees. Remember, that's 90, 180, 270, 360, just around the unit circle. So we should have 3 answers, 210, 270, and 330. Now, this will be our last one, but again, it's probably one of the most important ones. So again, if we look at those values, 0 to 360, so we're answering in degrees, it says round to the nearest tenth of a degree. But here's the big hiccup, guys. All right, I've got 3 sine squared x minus 5 cos x minus 1. All right, remember, you can't have 2 different trig functions. I can't just go ahead and factor this because I have a sine squared and a cos x. Okay, now, here's the other big hiccup. This is not a double angle like we just talked about. Okay, this is a squared term. And we find squared terms in one of 3 places. Those are the 3 Godfather rules. So let's slow down and remind ourselves what those are. These are not, and I repeat, not on the formula sheet. Sine squared plus cosine squared equals 1. Okay, to get the other ones, you divide everybody by sine squared. So that would be 1 plus cotangent squared equals cosecant squared. Or you divide everybody by cosine squared. So that gets me tangent squared plus 1 equals secant squared. Those are your 3 rules. So here's what you say. Because it's squared, that's the one I'm going to get rid of. I'm going to kind of bubble it in, cross it off. I want to get rid of that one. So I picked the Godfather rule or grandfather rule here that talks about sine squared. So that's this one here. You needed to say sine squared equals something. What do you do? Hopefully you're just saying take this cosine squared and boot it to the other side. So I'm saying sine squared equals 1 minus cosine squared. And I'm going to carefully substitute that in. So I'm saying 3 in parentheses. Sine squared is 1 minus cosine squared. minus 5 cos x minus 1 equals 0. Okay? There's one move there. Either you're going to do it right on the exam and get some points, or we're going to miss it and we're going to be in trouble there. Watch those squared terms. They come from the Pythagorean identities. Alright, now I got a lot of cleaning up to do before I go anyplace. So I can distribute this 3. So 3 minus 3 cosine squared x minus 5 cos x minus 1 equals 0. So that's negative 3 cosine squared x minus 5 cos x. 3 minus 1 is a positive 2. And again, a lot of people don't like to have that negative in front, so I'm just going to change everybody's sign. 3 cosine squared x plus 5 cos x minus 2 equals 0. Now, my gut tells me, since they told me to round to the nearest tenth, I'm not going to even try to factor. I'm just going to go quadratic formula. Alright, just for fun here, and because I don't know if it factors. So I'm going to say cos x equals, I need negative b, so negative 5 plus or minus the square root of my b squared minus 4 times a times c divided by 2a, which is 6. Cos x equals negative 5 plus or minus. Let's see, I get radical 49, which tells me this did actually factor nicely because that's a perfect square. So let's see, that's negative 5 plus or minus 7 all over 6. And let's get our two numbers. Cos x equals negative 5 plus 7 over 6. And cos x equals negative 5 minus 7 all over 6. As I continue cleaning, cos x equals, let's see, negative 5 plus 7 is 2/6, or 1/3. And cos x equals negative 12 over 6, which is negative 2. All right, now, these are not ones from our table, so you have to do inverse cos to get your answer. Inverse cos of 1/3, again, you're just typing in your calculator, and I think it said to the nearest tenth. I've got 70.5. Now, I have to slow down and get quadrants. Remember, every trig problem has quadrants. All students tip cows. We're cosine, and we want to be a positive 1/3. So 1 is a winner because everybody's positive, and 2 cosine's negative, and 3 cosine's negative, and in 4 cosine's positive. So I'm going to use 70.5, and I'm going to take my 360 minus that 70.5 and get, let's see, 289.5. Okay, on the other hand, I'm going to try to do inverse cos of negative 2, and hopefully you get an error, and that's a good thing, or a domain error. And remember, when I graph cosine, it only goes to a positive 1 and a negative 1, so anybody outside that range gets rejected. So that whole side is rejected, and we've got our two solutions. Well, we look forward to some good practice, and we'll see you tomorrow.